Hi everyone. In this tutorial, we will discuss the solution of stack implementation by using queue. So let's get started. So in this program, we will be performing three stack operation. The first one is push when we want to add something into queue. So that operation is push operation. And when we want to remove something from queue, we're going to perform pop operation. And when we want to know the top element of stack, for that we're going to perform peek operation. So let's quickly write one uh, method first, that is push, and the return type of this push method will be boolean. This push method will be expecting input of uh, element of integer type. So here, as we discussed, right, we're gonna implement the stack by using queue. So we're gonna use the help of internal queue, which will be expecting the input of integer type, and queue is equal to new linker list, right? Now here, whenever we are adding, we are calling push operation, so we will be adding those elements into queue. So this is very straightforward. Queue dot add, and we're gonna add element into this. All right, and we're gonna return the same because queue add method of this queue is also returning the boolean, and after performing this add operation, we are returning the same boolean value back to the caller method, right? So this is push operation. So let's implement another operation, which is pop, public. And in pop, basically we're gonna return integer, right? Because we are inserting the integer type of element, and we're gonna return the popped element or removed element back to the caller method. And let's call let's create pop method, and this pop method won't be expecting any input parameter. So here we're gonna check first if queue is empty, because we have use case. If let's say queue is empty and we still trying to delete something from queue, so in that case we're gonna throw exception, right? Stack underflow, because we can't delete anything if there is no any element into stack. So stack implementation is queue, which is the behind to this stack, right? If there is some element which exists in the stack, in that case we have to perform the pop operation. All right, so how we are going to do that? Let's do that by using queue dot remove, right? And let's return this back. Let's write quickly main method to test both of this method and see what's the behavior of these two methods, because there is some issue in this pop method, right? As we are implementing the queue behind this stack, so there is some limitation of this. We have to fix it, but let's try running these couple of programs, couple of methods, and let's verify what's the issue, and then we'll fix this issue. All right, so stack with queue, stack is equal to new stack. So we are creating an instance of current class, and let's call push operation. Let's pass 10, 20, and 30, right? And let's call uh, pop operation now. Stack dot pop, and yeah, it is throwing exception if your queue is empty. In that case, we have to throw this the same exception to JVM, right? Now let's run this. So our first element which we have pushed into stack is 10, second is 20, and third one is 30, right? And this is the last element, and as we know, right, stack worked on LIFO, last in first out principle. So we are expecting the element which we have inserted last should be eligible to delete first, means this 30 should be deleted. So let's give message here, removed element is, so in this case it should return 30, but it won't return. Let's run this once. Let's verify why, what's the output of this, and why it is not printing 30. See, it is printing 10, which is the element which we have inserted first. Now let's discuss why this is happening. As our expectation is something different, but our program is uh, returning something different output, right? So let's discuss why this is happening. So uh, we have created a stack, something like this, right? And this is working on last in first out principle. And we have elements 10, 20, 30, which we tried inserting into stack, 10, 20, and 30, right? So we have inserted like this, 10, 20, and 30. So in normal stack, uh, this looks like this. The representation of these elements looks like this, right? And when we are expecting to remove 30 by calling the pop operation, all right? But this is not happening. Why this is not happening? Because the implementation of stack, like we have done by using queue. So internal, it is storing the elements in this fashion, right? We are inserting the element from this end and popping the element out from this end, right? So when we have inserted the element, it is represented in the queue like 10, 20, and 30. So this is the insertion part, right? And this is remove part, right? So whenever you are inserting, you're adding any element into queue, so you are adding from this end, and when you want to remove it, you won't be able to remove from this end. You have only option to remove from front end. So the first element which you have inserted is eligible to remove first. That's why it worked on FIFO. This queue worked on this FIFO principle. First in, first out. So first element which you have added in the queue is 10. That's why it is applicable to remove first. That's why your output is coming 10. Now, what we should do so that our queue should also behave like a stack. So that is one another uh, problem, right? Now let's see how we can resolve this issue. So what we can do as our element 10, sorry, just a second. Yeah, 10, 20, and 30. So we took one queue, that is q1, and our queue is something like this. So we will be taking a help of one another queue, and an element we have added into queue is 10, 20, and 30. Now as we are popping out, so right now we have access to pop out first element which we have added here, right? This, and we are expecting to remove the last element which we have added recently. How we can do that? So what we will do, we'll take a help of another queue, q2, right? And we'll be creating a q2. So we will be keep removing the element from first queue until our size of first queue will not become 1. So right, like q1 dot size, right? If it is not become 1, so keep removing element from uh, first queue. So when we are removing the element from first queue, so those removed element we will be keep adding into second queue. So let's say we removed the element which is the first element which is 10, and we have added that into this. Now we are trying to remove the second element. Well, we will be checking whether size of the queue is 1 or not. First queue, it is not 1 because we have two element. Size is 2. Again, we will be removing this element and we will be adding into this queue, right? And now in third iteration we will be checking the size of first queue is 1 or not. Yes, it is 1. In that case, we will be removing element from q1, right? But we won't be adding into this. We won't be adding that removed element into q2. We will be just returning this removed element back to the caller method, right? And now our logic is performing the operation on q1, but our element, all the elements from q1 to q, I mean we have shifted elements from q1 to q2 from here to here. But in next time when you perform the pop operation again, so element should be there in q1 so that it can be able to add the it can be able to perform the operation on q1. So for that we will be assigning uh, q1 is equal to q2, means whatever elements are there in q2, those elements should be also be available in q1. So your q1 will become, sorry, your q2 will become q1. Whatever is there, it will be also present in this. Now when you perform the pop operation again, so your q1 data will be available. Let me show you. So it will be the data will available like this, 10 and 20. After performing this step, q1 is equal to q2, so your data will also be available in q1. So this is how we are going to resolve this issue. Now let's go back to code and let's try to modify our pop operation. So before removing the elements from here, we're gonna take one temporary queue. So let's give this queue name as q1 so that it will be easy to understand, right? Q1. Okay, and from here we're gonna create one another queue, that is, let me copy the same here so that we can save time. And we have created another queue, that is q2. So now here we're gonna check while uh, q1, sorry, q2 dot size, if it is not equal to 1, if it is not equal to 1, you have to keep iterating and on each, sorry, this should be q1 because we are trying to check the size of q1, the one which we have discussed, right? Size of q1, because we need to remove the element from q1 to q2. So we are checking the q1 size. If it is not equal to 1, then do one thing, q1 dot remove the element from q1 and add the removed element into q2. q2 dot add, we are adding the same removed element from the q1 to q2, right? So once we reach, once the size of q1 is 1, right? In that case it won't come inside this while loop, it will exit from here, right? And what we will do, we'll create one integer variable, removed element is equal to uh, q1 dot remove, because now here I'll show you again. So when we have only single element in the queue, it is again all. So this is again 10, 20, 30. This is q1. We have 10, 20 and 30, and here we have already copied 10 and 20, right? We have deleted element from here. Now the size of q1 is 1 only. Now we have to delete this element, but we won't be adding the last element into this queue. That is what we are doing. As size is 1, right? size is 1, it won't enter inside this while loop. It will exit from here, and here also we have to perform the remove operation for the last element. Removing last element from Q1. Alright, now we have removed it. So once the remove operation is done, we're gonna return the same back to caller method, removed element. But here we are missing one step. Now if you're performing the pop operation again, so in that case your Q1 is empty because you have removed the element from Q1, right? So I'm talking about this one. So we have removed this 30 also. All right, now Q1 is empty, this is Q2. So in that case, we have all the elements now in Q2. So before performing the another operation, or before returning the deleted element, this is return, right? 30. So before performing the return operation, we have to assign Q2 to Q1, so that next time our pop operation will able to perform the operation on Q1. So what I'm saying is, here before returning the removed element back to the caller method, we have to perform Q1 is equal to Q2, means whatever element are there in the Q2 should be available also in the Q1, and then we can perform the return. We can return the removed element back to the caller method. Now let's run this program again and let's see whether we are able to delete 30 or not. Yeah, removed element is 30. Even we are using Q in the backend implementation of stack, but it is deleting the recently added element from the stack. It is not removing this one. Even the principle of the queue is different, but we have implemented the queue in such a way that it should always delete the top element and return the deleted element back to the caller method. All right, now let's perform the peek operation. So peek operation is also similar, but in this we were deleting the last element. We were not adding, right? We were deleting the last element and returning back. But in case of peek operation, we have to add this element also in the Q2, because peek won't be deleting anything. It will just return the topest element. All right. So in that case, we also need to add this uh, last element into Q2, that is 30. So let's see how we can do that. I'm just copying the same uh, method again, and we'll do a little modification in this. So this is peek. All right, and if it is, in case of peek, if it is empty, right, in that case also we're gonna throw stack underflow exception. We're gonna test this also. So now here we are checking Q1 size is uh, not equal to 1. If it is not equal to 1, then keep removing the element from Q1 and keep adding those removed element to Q2. Now when we have only one element left in the queue, it won't come inside a while loop. It will exit from here. So here we are removing it, right? That's that step we have to do, but the removed element should be added in Q2. So Q2 dot add, that is removed element, right? Because here we are removing, now we have to return this removed we have to return this removed element back, but this entry should not be deleted from the queue. This should be exist when we are performing the peek operation, right? In that case, this entry should exist in the queue. So that's why we are removing it from here, but once we removed, we are adding the removed element into Q2. See, we are removing and then we are adding into Q2 and then we are assigning Q2 to Q1, right? And this should be top element, top element. All right. Now let's check uh, out. Top element is stack dot peak. Now let's see this before performing the pop operation. Now the top element should be, as per our logic, the top, and as per our logic and as per the uh, stack convention, the top, so the peak operation should return the top element, which is 30, and after performing the peak operation, sorry, after performing the pop operation, it should delete the 30 element, and then after deletion of your top element, your next top, your recent top should be, or your latest top should be 20. This should be the output. So let's run this again. Yeah. So top element is 30. You have removed the top element, which is 30, and when after removing the top element, you performed peak operation and it returned the latest top element, which is 20. Let's say you are removing top again. Let's perform this. Now your top element will be, okay. So you're performing this operation again. You are basically performing the peak operation, pop operation 2 times. You are deleting all the elements from the stack. Now in that case, for the last pop operation, you should get exception. Okay, you have performed 1 and 2 and 3. You have performed 3 times pop operation, you have 3 elements. But when you perform the pop operation 4th time, in that case, there is nothing inside the stack, so you will be getting exception. See, stack underflow, because there is nothing. If you delete this and when you perform the peak operation on first element, first queue, so it will also return the same stack underflow error. See, stack underflow. So not in this case. In case of pop also, if there is nothing inside your stack, but you're trying to remove, something from stack, so in that case also it will return you the stack underflow exception. See this. But when you have something, you can perform the pop operation. See this, the popped removed element is 10. So the implementation of stack by using queue is working fine. So that's all from this video, guys. Thank you so much for watching this video. Stay tuned for other videos. Thank you.